I'm athletes. Today we're going to investigate patterns, and this time we're going to use magic squares. So, first of all, let's review what consecutive numbers are. And these are numbers that follow each other. For example, 1, 2, 3, or negative 1, 0, 1. We call them our counting numbers, and they can be positive or negative numbers. Now, when you're looking at a magic square, it's a square grid that contains consecutive numbers without repeating them. And each row, column, and diagonal add up to the same number. This sum we call the magic sum. So here's an example of a magic square where the magic sum is 15. Notice that we have our consecutive numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, and none of them are repeated. So if you notice here, every row has the sum of 15. 8 plus 1 plus 6, 3 plus 5 plus 7, 4 plus 9 plus 2. Also, every column has a sum of 15. 8 plus 3 plus 4, 1 plus 5 plus 9, and 6 plus 7 plus 2. And lastly, both of the diagonals have a sum of 15. 8 plus 5 plus 2, and 4 plus 5 plus 6. So that makes it a magic square. Now let's see if this is a magic square. Let's check first with our rows. Well, our rows add up to 15. 4 plus 3 plus 8 is 15. 9 plus 5 plus 1 is 15. And 2 plus 7 plus 6 is 15. The columns also add up to 15. 4 plus 9 plus 2, 3 plus 5 plus 7, and 8 plus 1 plus 6. And lastly, the diagonals. The sum of 4, 5, and 6 is 15, and the sum of 2, 5, and 8 is also 15. So it's indeed a magic square. So this is a magic square, but I left some of the numbers out, and I also didn't tell you what the magic sum is. So let's see if we can figure out the magic sum and fill in the missing boxes. All right, so I noticed here that there's a box missing here, so I can't do this column. And there's one here, I can't do the row. So I can't do any of these columns or any of the rows. But I do notice that we have a diagonal here. And that diagonal is 4 plus 7 plus 10, which is 21. So the magic sum is 21. So now let's see if I can figure out this box in yellow. Well, I know that 4 plus 8 is 12. So if the magic sum is 21, it's 21 minus 12. So the missing number must be 9. All right, let's look at this one. So I know that 8 and 10 is 18. So 21 minus 18 is 3. Okay, how about this one? Looking at the 7 plus the 3, which is 10. So 21 minus 10 is 11. And then this one, I have the 4 plus the 11 is 15, and 21 minus 15 is 6. And then this last one, I could do the 7 plus the 9 or the 6 plus the 10. Let's do the 9 and the 7, which is 16, and 21 minus 16 is 5. But I also could have done 16, which is 10 plus the 10 and the 6, and then 16 subtracted from 21 is also going to be 5. And we can again look at this as our counting numbers, this time starting with 3. So 3, 4, 5, 6, 7, 8, 9, 10, 11. So our consecutive numbers and only used once. Now let's try doing a magic square, but this time we're going to do a 4 by 4. And let's see what our magic sum would be. Oh, I see the diagonal here. So we're going to add 8, 5, 9, and 12, and the sum's going to be 34. Now let's try this missing one. So it's going to be 16 because 9 and 7 and 2, if we add those together, is 18. And 18 subtracted from 34 is going to be 16. Now let's try this one. And this one's going to be 13. This one is 3. This one, 10. I'm going to add those together and subtract it from 34, so 4. So I can go this column, 1, and 14. So do you get the hang of it? That's how magic squares work. So now we're going to investigate some patterns with magic squares. So here's a magic square, and let's see what the sum would be. Remember, the sum, we can use either the columns, the rows, or the diagonals. Okay, and I'm going to use this diagonal. So -2 plus -1 is -3 plus 0. So the magic sum is going to be -3. Now, let's add 1 to each one of the squares. So for example, if I add 1 to 2, this square is now going to be 3. -5 plus 1 is -4. 0 plus 1 is 1, etc. Did it for all of them. Now let's figure out our new magic sum. Well, our new magic sum is 0, because if we add this together, 3 plus 0 plus -3 is 0. -1 plus 0 plus 1 is 0. So our new magic sum now is 0. Let's try another one. Again, I'm going to use the same magic sum as -3, but this time let's add 2 and see what happens. So there I am adding my 2. So 2 plus 2 is 4. -5 plus 2 is -3. And again, let's find the magic sum. So the magic sum for this would be 2 and -2 I know is 0. So my magic sum now is 3. And let's try one more. Again, the same thing as a magic sum of -3. And this time, let's add a -3. So 2 plus -3 is -1. 5 and -5 and a -3 is -8. And again, we can use diagonals, rows, or columns. Let's use this column. So -8 plus -4 is -12 plus 0 is -12. So our magic sum is -12. So here we have the other screen. I just shrunk it a little bit. And now let's look at this in a table, because sometimes it's easier to see a pattern if we have a table. So the original sum I'm going to put in red, which is that original magic sum, which is -3. The number added right here is in blue, and our new magic sum is going to be in the purple. So in the first one, the magic sum is -3. If I don't add any numbers to it, the magic sum will stay the same as -3. For the first one we did, our magic sum was -3, but we added 1, and we found that our new magic sum was 0. For the next one, again, the original magic sum was -3. This time we added 2, and our new magic sum was 3. And lastly, again, the original magic sum was -3. This time we added a -3, and our new magic sum was -12. So what is the connection between the number added and the magic sum? You might want to pause here for a moment and see what kind of ideas or conjectures you can come up with. So here's some things that I noticed. I noticed that there are 3 squares being added together. So we always have to add 3 squares to get our magic sum. I also noticed that when I added 1 to each square, in this one right here, that the sum increased by 3. So for example, I started with my magic sum as -3, and then I had to add 1 to each one of the 3 squares, and then I got a magic sum of 0. When I added 2 to each square, the sum increased by 6, because I had to add 2 to each square. So 2 plus 2 plus 2, which is 6, and they gave me a magic sum of 3. And lastly, when I added -3 or took away 3 from each square, the sum decreased by 9. So I added a -3, a -3, and a -3 to each one of the 3 squares. And -3 plus -3 plus -3 is -9. So -9 and -3 is -12. So now let's predict the magic sum if we subtract 5 from each of the numbers in the original magic square. Well, that means I need to subtract 5 from each of the 3, right? Because here I added 1 to each of the 3. Here I added 2 to each of the 3. I added -3 to each of the 3. So this time I'm going to add -5 to each of the 3 squares. So I start with my original sum, -3, and then add -5, -5, -5. And that's going to give me -18 as my new magic sum, because -15 plus -3 is -18. Now let's verify or check to make sure that our prediction is correct with our new magic sum. So here's our original magic sum of -3. Again, I'm going to add a -5. So here's my new magic square. And the magic sum should be -18. Well, let's check it out. So if I have -9 plus -6 plus -3, that does indeed equal -18. -6, -10, and -2 also add to -18. So it looks like it works. Now let's see if we can write a rule to find the magic sum for a changed magic square. So if we have our magic sum, we would look at the original magic sum here, and then we could add 3 and multiply it by the change in the number. 3, because remember we have 3 squares. We keep adding it 3 times or subtracting it 3 times. And this is what we're changing in here. Let's look at it this way. The magic sum is -18. The original was -3. We are going to use 3 numbers because it's a 3 by 3 square. And we're going to multiply it by the change, -5. And -18 equals -3 plus -15. And -18 does equal -18. So it looks like it checks out. We verified it. Okay, now let's choose our own values to add or subtract to each of the numbers to investigate the effect of the magic sum for a 4 by 4 magic square that we completed earlier. So here's our 4 by 4. And our original magic sum for this one was 34. So let's add 4 to each one. And there we go, we add 4. And our new magic sum is 50. Trust me on that one. Okay, so now let's do another one, but this time I'm going to add 10. And my new magic sum is 74. And now I'm going to add a -2, and my new magic sum is going to be 26. Okay, I'm going to shrink this. There it is. And again, we're going to make a table. Sometimes, again, it's easier to see our patterns in a table. So we know that the original magic sum is 34. For the first one, we would add 0, and the magic sum would still be 34. Then our first example that we did, we added 4, and our new magic sum was 50. The next one, we added 10, and our new magic 4 was 74. And the last one, we added a -2, and our new magic sum was 26. Now, what is the connection between the number added and the magic sum? Think about what we did before with our 3 by 3. Did you see any patterns? Well, now I notice that 4 squares are being added together instead of 3 squares. And when I add 4 to each square, the sum increased by 16. So if I originally had my 34, I added 4 times. 1, 2, 3, 4, because 4 squares are being added together to get my magic sum. And that sum together for my new magic sum is 50. When I added 10 to each square, the sum increased by 40 because I had to add 10 4 times because there were 4 squares. 10 plus 10 plus 10 plus 10. So that gave me 74. And when I had to take away 2 or add -2, I had to do it 4 times. So my new magic sum was 26. So let's write a rule to find the magic sum for a changed 4 by 4 magic square. So our new magic sum is the original magic sum, but this time instead of adding the 3, we're going to add 4 multiplied by the change in number because it's a 4 by 4 magic square. In other words, we had to add to each one of the 4 squares. So do you think our rule for the magic square would work for any size? Well, let's look at our rules so far. So far, we know that a 3 by 3 magic square, we have the new magic sum is the original magic sum plus 3 multiplied by the change in number. We know that a 4 by 4 magic square is a magic square which equals the original magic square, but this time plus 4 multiplied by the change in number. So the only thing that changed is the 4 from the 3. So what might a rule look like for a magic square of any size? Well, again, the magic sum is going to be the original magic sum plus, and instead of a 3 or 4, it's the number of squares in a row. Because there's 3 squares in a 3 by 3 in a row. There's 4 squares in a 4 by 4 in a row. So the number of squares in a row, and again, we're going to multiply that by the change in number. So here's a 3 by 3 magic square rule. So we said that the magic sum equals the original magic sum plus 3 multiplied by the change in number. So let's use our rule to predict a magic square, the magic sum, for a 3 by 3 magic square. The original magic square is -3, and we're going to add 4 to each square. So here we go with our equation. The magic sum equals the original magic sum plus 3 multiplied by the change in number. Let's replace our words with some numbers. So the magic sum equals, the original magic sum is -3. It's going to be added to the product of 3 multiplied by 4. 3 is because it's a 3 by 3 magic square, and 4 because we decided to add 4 to it. And now we're just going to simplify. The magic sum equals -3 plus 12, so our magic sum is 9. Now let's verify it with actually making a magic square. So here's our original magic sum, -3. We're adding 4, and here's our new magic square, and the magic sum should be 9. And if we check it out, we can check some of them. 6 plus 3 is 9, 2 plus 3 plus 4 is 9, -1 plus 3 plus 7 is also 9. So it looks like it checks out. Now let's try our 4 by 4 magic square rule. Again, the only thing that changed was now the 4 because there's 4 squares in a row. We're going to use this rule to predict the magic sum for a 4 by 4 magic square. This time the original magic square has a sum of 2, and we're going to add 6. Okay, so here's our equation that we have. We're going to replace the words with the numbers, so the magic square is going to equal, the magic sum is going to equal 2, because that's our original, plus 4, because there's 4 squares in a row in a 4 by 4 magic square, and the change of number is 6. Okay, the magic sum equals 2 plus 24, so our new magic sum should be 26. Let's check it out. Here's my magic square with the original magic sum of 2. I'm going to add 6, and here's what it looks like. So the magic sum should be 26. And again, we can check that out by adding. If we did 11 plus 0 plus 1 plus 14, that's 26. We could look at a diagonal. -1 plus 5 plus 8 plus 14 is 26. And 2 plus 7 plus 3 plus 14 is also 26. So I hope that you enjoyed this. This is a way to use something fun like a magic square to come up with our own equations and then verify to make sure that they work. If you like this one, check out some of my other patterns that I've done, and hopefully you would like those as well. But as always, thank you so much for watching.